Hello everyone, my name is Rajat, a former Microsoft engineer and an educator and founder at Bosscoder Academy. Welcome to this class. In this class, we are going to learn the scalability aspect of messaging platforms like WhatsApp. I hope you love the class.
So let's start with whenever you are given a system design problem, right? The first thing that we should do is we should try to figure out what is the MVP of the product or what are we actually building? What is the problem statement? What is the MVP? MVP is a minimum viable product. Let me explain this with WhatsApp example. Can you tell me what are the different features that you see within WhatsApp? Let me start with one. The one feature that I see is that I can send someone messages one-on-one. What are some other things you can see? Yeah, definitely we can send text message, we can send photos, we can send videos, we can send attachments, multiple things. Yes, we can do calls. There are audio calls, there are video calls. What else do you see? Attachment I have. There are status, definitely. There are status on WhatsApp. You can see those. There are payment as well. Yes. There is UPI payment as well. You can do payment as well. Emojis, definitely you can share emojis, react to messages, right? I would say react to messages. Yeah, you can share a bunch of things. You can share location as well. Yes, there are even group messages, definitely. Okay, what else? There is a web version of WhatsApp known as WhatsApp Web. Yes, there is also, you can broadcast message as well, right? There is also seen, you can also see the status of the messages. For example, is it seen, is it received, or is it delivered? You can see status of the messages. You can store the backup of the messages on Google Drive or any other drive or Apple Drive, whatever it is, like Apple Cloud, iCloud, right? Yeah, you can create a profile as well. You can create DP, multiple things, have your status written there, multiple areas, right? You can change the background of chat as well. There are so many features of WhatsApp. Now tell me, when WhatsApp would have launched first, does it have all the features? When you first use WhatsApp, I remember I used WhatsApp when I was in, I think, 11th class. That was the first time I used WhatsApp. Does it have all those features? Does it allow sending payments? Does it allow doing like a lot of things that it does right now? No, right? No, right? So whenever a product starts or whenever a company starts, it starts with the MVP product, which is some set of minimum viable products, but the best features that you actually stand for. Roll out these features to your users. Users start trying out those features, and then based on the feedback, they either improve or add more features. That is how a product life cycle looks like, right? So whenever you are designing a system in a company, you really need to understand what is the requirement of the system. So that is very important. Even if you are in an interview, giving a system design interview, very, very important is to understand and conversation with the interviewer to really understanding what are you actually building. WhatsApp is a very broad problem. Okay. So now what are we building today in this session is we are definitely building chat messages, right? We will talk about text messages. We will talk about photos and videos as well. We will talk about this. We are not discussing calls. We are not discussing status. We are not discussing payments as well. Again, a very different thing. Building a whole payment app is a completely different area. Call video is again a different, completely different area, which we have covered in previous classes. React to messages we will discuss. Group messages we will cover. Web version of WhatsApp we will not cover. Broadcast we will not cover. Scene we will not cover. Backup we will not cover. Profile creation we will cover in today's class, right? So does this make sense? Like, what are we building in this class? So in this class, we are building a chat application at scale, where someone can do one-on-one conversations, one-on-one messages. They can create their profile, right? They can react to messages. In messages, they can send either photos, videos, or text messages, right? And of course, they can send group messages. This is what we are discussing right now in this session. We can cover it's very simple. If we get the time, we will definitely cover the scene. Or you can ask it in the end and I will just cover it, right? Just remember in the end, in open-ended Q&A, just ask me and I will cover it. It's usually very simple. You will able to come up by yourself as well. Okay, does this make sense? A quick yes if this is clear. Okay, great. What are we building is clear, right? We are building this. So we are building a chat application which support all of this, which is very, very important for you to do whenever you are either working in a company or you are working or you are in an interview, right? Before scale estimation, let me also talk about a very quick difference between WhatsApp and other chat applications like Telegram or Messenger or Slack or Microsoft Teams. All of these are basically gives you a capability of doing chat. However, how is WhatsApp different? Can you tell me one major aspect? Or Discord, right? They support chat in one way or another. But what do you think? What is the major difference between WhatsApp and Telegram? If I say both of them are very chat centric. User is of course like one thing. Encryption, yeah, definitely. One thing that is very like that is going to change the design a lot. Okay, looks good. One thing, yeah, some of you are already writing this. So one thing that is very, very different that is going to change our design a lot is WhatsApp don't store messages that you are writing privacy and handling messages, right? Like don't store messages in their database. So let's say if Rajat is sending a message to, let's say, Karthik, right? Let's say Rajat is sending a message to Karthik. So can you tell me if you are on Telegram, if Rajat is sending messages on Telegram, and let's say this is the Telegram system, then Rajat is going to send a hi message, let's say, then Telegram is going to store this message and then is going to send it to Karthik, right? Whereas WhatsApp is a bit different. What happens in WhatsApp is, if Rajat is sending a hi message on WhatsApp, then WhatsApp is going to receive this message, so WhatsApp will receive message. If I just write it in here from Rajat, then it will store the message in its DB, right? In DB, in database, then is going to send the message to Karthik. And if the message is sent, then it will delete the message. Right? So it does not actually go about storing messages into their databases. Does it make sense? And that is going to have a lot of impact on how do we handle storage within, how are we going to handle the storage of messages, right? Is it clear? That is why it asks you to backup messages, right? And it backup messages on Google Drive. But Telegram will not ask you to backup messages because it is already backup messages on their databases. Is it clear? A quick yes, no, if this is clear, right? Any question till now? Okay, No, what is not clear? It's just that WhatsApp does not store your messages, right? Please be attentive again, as I am saying. Again, how is WhatsApp hacked is you basically back up your message on Google Drive, and then the messages are retrieved from your backup, right? For example, I also back up my messages on WhatsApp. But let's say if you don't back up your messages on WhatsApp and your phone is lost and you buy a new phone and then log in on WhatsApp, you will not be able to get their old messages. WhatsApp will not give you your old messages. It's stored in your local. How are you able to see next day messages? Because you are storing messages on your local mobile phone, not on the WhatsApp database. You are storing it locally. Okay. No, it does not have an auto backup. Try it. Disable backup on WhatsApp. Try at your own risk. But just then open WhatsApp on a new phone and your messages will not be available. Is it a good design practice or not? It does not have to do anything with design. It is that what is your use case, right? What do you believe in? As a company, this is a feature that they are providing, that we will not store your message. Your messages are private to you. No one is going to see your messages for sure, right? And that is how they are working on it. Okay, makes sense. Should we move forward? We will cover some of these questions. Definitely. What does end-to-end encryption means? I will cover it in the end. Okay. Okay, makes sense. Again, I am not saying it deletes instantly. It definitely stores for some amount of time. I will discuss it in the end, right? Okay. Okay. What we can also do is, if you have questions, other people can also reply to those. For example, how can police get to know? Again, you might have backed up your messages on Google Drive. For example, I also back up my messages of WhatsApp on Google Drive. Now, WhatsApp does not store it automatically. How does WhatsApp web work? WhatsApp might be storing messages for some point of time, maybe a week, but after a week they delete it. Right? So we will discuss some of these aspects. Just give me some time and you will get the clarity of these. Okay, so this is clear, right? Good. Makes sense. Should we move forward? Okay, great. So let's do some scale estimation after this. Now we know what are we designing, what are we actually designing. Let's understand what is the scale we are designing for all the users. Let's design for at what scale are we designing it. In scale, let's discuss two things: storage and QPS. What is QPS? I will cover in some time, but let's start with storage, right? So a lot of people are asking this question that, okay, how does WhatsApp web work and all of it? Let's see some of the aspects of it. So let's see certain scenarios and you will try to get sense of it, and then we will understand how much storage do we require. Let's say this is the WhatsApp system. This is Rajat. Rajat sends a message to let's say Akriti, right? Let's say Rajat sends the message to Akriti. Rajat sends a hi message to Akriti. Let's say if the message is gone to the WhatsApp server, let's say it is delivered to Akriti mobile phone. Do I need to now keep this message? No, right? I can just delete this message, right? So at this point of time, I can delete this message. But let's say Akriti is offline. Then what to do? What if Akriti is offline? then I cannot delete this message, right? Because I have to deliver this message to Akriti. So I will store this message until it is delivered, right? I have to persist this message until it is delivered. And I can have an expiry that, okay, after 6 months, if still the message is not delivered to Akriti, I will delete the message from my database. Even after 6 months of sending it, I am not able to deliver it. This can be something else as well. This expiry can be something else as well, right? Does this make sense? Like, how can we go about doing so? Right? So there are certain scenarios that now I see. One scenario one that I see is right now is Rajat sends a message to Akriti and Akriti is available. So the message is sent instantly. Right? Does this make sense? In this case, I don't need to store the message. And I can delete it instantly or delete it after some point of time, which is my threshold, whatever it can. Right? The second scenario is that Rajat sends the message to Akriti, but Akriti is not available. So I have to store the message in this case and keep on retrying. Does this make sense? And I have to keep on retrying that, okay, let me send this message, let me send this message, let me retry sending this message, right? Does this make sense? In this case, I have to store the message. Okay, these two scenarios are clear, and then let's talk about interval of retries. We will cover it again. We will retry in exponential decay. In exponential decay manner, we will cover it. Give me some time, we will cover all of it. Right? Are the two scenarios clear? And then let's move forward. A quick yes if this is clear, and then let's move forward. Okay, great. These two scenarios are clear. Great. So now tell me how many users you think are there on WhatsApp. Which are basically, you can think of as a daily active users. People who are active on WhatsApp per day. There are total 6-7 billion people on Earth, Vidika. So it will not be 6 billion. Right? So we can say around 1 billion people. There might be more as well, since WhatsApp is very, very popular. But let's say, as we are doing scale estimation, let's say there are 1 billion people which are using WhatsApp every day. What do you think on an average, how many messages they send? $40, $50, right? Like we can do anything, right? Let's say 40 messages they are sending per day, right? On an average. Again, these are estimations, not actual numbers. So we are just estimating. So how many total messages are sent per day on an estimation? There are 40 messages sent by each user per day, and 1 billion users. This is per user. And there are 1 billion users, right? So there will be 40 billion messages which are sent per day on WhatsApp, right? Now, if you see what will happen with these 40 billion messages. Some of these messages will be sent within an hour, right? Like say other person is available. So this message will be sent immediately and will be deleted from the server, right? Does this make sense? Okay. Some messages will be sent within 6 hours. So this can also happen. Let's say I am on a movie. I am going for a movie and I have switched on my mobile. And then after the movie is completed, I open my mobile. So then I will receive the message, right? So after small interval, let's say 1 hour, 2 hour, 3 hours of non availability, right? Or it can be sent within a day or within 6 months, right? Does this make sense? Until we hit an expiry. Does this make sense? Is this clear? A quick yes or quick no. Is this making sense? It is stored in your local, right? Right, Mayashri. So once a message is sent to you, you just switch off your internet, right? Like just do one thing, switch off your internet, switch off your Wi-Fi and open WhatsApp. Will you see your old messages? Tell me, like if you switch off your internet, switch off your Wi-Fi, will you still see your old messages? Yes, right? So are you getting the messages every time from the server? If you are getting from the server, then you will not be seeing your messages, but you still see them. Why? Because these messages are cached in your local device. Do one thing, go to settings and go to WhatsApp and see how much storage WhatsApp is taking right now. You will see that WhatsApp is taking a lot of your storage. Why? Because WhatsApp is storing all the chat messages that you are doing right now. It will store all the photos that you are storing right now in your local device, not on the web, not on the internet, but on your local device. And that will account for your storage. And your storage is filling out. Right? So it's cached on your device. It's not like you're going on the server every time. Okay. No, Ravi. Do it, try it by yourself. If you don't back up the message and you move to another mobile phone, you will not see any messages. You will not get any message. You will start from zero. No, WhatsApp does not store in server. No, message will not be delivered. Right? Okay. Is this clear? A quick yes. And then let's move forward. So you have to understand that how much storage. So what is happening with WhatsApp storage? If you understand it, please be more attentive, right? Like I will take up questions, but please be more attentive. Otherwise you will miss things. So what is happening with WhatsApp storage is a lot of users are adding messages, right? Whereas WhatsApp is also sending messages and deleting storage and deleting those. Does this make sense? So from the storage of WhatsApp, messages are not just incoming. They are incoming as well and they are outgoing as well. So the WhatsApp storage is getting filled as well and getting removed as well. Do you understand this point? Is this clear? In Telegram, this is not the case. In Telegram, messages are just getting filled from users, but no deletion is happening. But in WhatsApp, deletion is happening. Right? A quick yes, if this is clear. How it is deleting, there is an expiry. We will cover it in some time. Right? So what we have to do in terms of understanding the storage estimation is to take one period of time and understanding on an average at one particular time, how much storage does WhatsApp store? How much data does WhatsApp store? Right? At one particular time, how much storage does WhatsApp hold to? Is this clear? Make sense? Right? Great. So this is clear. This is clear. So great. Right? So let's find out that how at one particular time, how much storage is getting stored. So we have total 40 billion messages per day. Few messages are there in storage for only 1 hour. Let's say 80% of messages are sent within an hour, right? Let's say another 15% of messages are sent within 8 hours. And let's say another 5% of messages are sent within 1 day. And we have an expiry of 1 day. Right? Let's take this example. Let's take this example and let's move forward with this. Right? So now tell me, how will you calculate how much time, how much messages will be there at one point of instance? Tell me, how will you calculate at one point of time? If we take this as an example, is we have total 40 billion messages. 80% of the messages are stored for 1 hour. 15% of messages are stored for 8 hours and 5% are stored for 1 day. Then how will you go about calculating? Yes. So Pankaj is doing right. What will be 80% of 40 billion messages? These messages are there for 1 hour. So for a particular period of time, how many messages will be there? Similarly here, 15% of messages are for 8 hours. So how many for one particular period of time, how many messages will be there? Similarly here, right? 5% messages are there for 1 day. So how many messages are per day, and then divided by how much time is there. And you will kind of get that, okay, if I take one period as 1 minute, then how many messages are there every minute on the database on an average, right? Does this make sense? I will not do this whole calculation because then it will take a lot of time. But is this making sense? Like, how can you, if you really want to do it, how can you go about doing this calculation? Making sense, right? Yeah, I can repeat once. So what we can do is that there are 40 billion messages. 80% of these messages are sent within 1 hour. So what will be 80% of 40 billion messages, which are there for 1 hour of period? And then I can find out that, okay, for 1 minute, how many messages will be there, right? If 1 hour, there are this much messages. So for a minute, how much many messages are there? Similarly for 15% and similarly for 5%, right? And you can find it out. Let me right now, let's not do this calculation, and let me say that on an average, there are 10 billion messages that are stored on WhatsApp for any particular point of time. Right? Let's say this is the case. What is point is something that you can decide, Pankaj. I think it will not be a second. We should definitely take a point as somewhat bigger period of time. And that can be 5 minutes, that can be 10 minutes, that can be half an hour, that can be 1 hour. Right? You can take according to it. Right? But let's say, yeah, interval can be like 30 minutes, right? So let's say there are 10 billion messages that are stored on WhatsApp for any particular point of time. Now tell me, what does a message consist of? How does one message looks like? There is definitely message ID. What else do you see in a message? There is definitely the message content, which is going to be text. There will definitely be timestamp, definitely at what time the message is sent. Yes, there will be receiver detail, receiver ID. There will also be sender ID. Yes, length of messages can also be there. Message signs, which client it is sent from, the client ID will also be there. Type of message, which type of message it is, which can decide how to look for a UI, which protocol is used. Yeah, definitely. Like a lot of these details are sent on a message. So what do you think? How much storage will one message will take? How much on an average it will take to store one message? It will be in KB, right? It will not be in MBs. It will not be that huge. Even if images are there, images are not stored in messages itself. Images are stored some like is not stored in a message kind of DB, not in a queryable format, not in like SQL kind of DB. It is stored in basically these kind of formats, right? For example, AWS S3 or blob storage is where images are stored. Right? So average it will store around, let's say 1 KB. Let's say it is around 1 KB, or let's say, yeah, we can say 1 KB or 5 KB. Like for ease of calculation, let's say 1 KB. It is taking to store one message. So how much storage requirement do we have at one particular time? There are 1 billion messages and each message is of size 1 KB. So what is the total storage requirement? 1 KB into 10 billion. To do these calculation, you can do like this. 1 billion is equals to 10 raised to the power 9 and 1 million is equals to 10 raised to the power 6. You would already know this, just remember this. And this will be 1 KB into 10 raised to the power 9, since it's a billion, right? So it will be 10 KB into, I can write 10 raised to the power 9 as 10 raised to the power 3 into 10 raised to the power 3 into 10 raised to the power 3. Okay. What will be 1000 KB? 1000 KB will be a MB. What will be 1000 MB? 1000 MB will be gigabyte. What will be 1000 gigabyte? A terabyte, right? So this will become 10 terabyte of storage. Okay. Makes sense? So on an estimation, we are storing around 10 terabyte of data at any particular point of time on WhatsApp, according to how we are designing WhatsApp, what is our design looks like, right? That we are storing messages for some period of time, for 1 hour and then evicting them for 8 hours or 24 hours. Yes, overall, at any one particular point of time. If we consider 1 billion users and 40 messages per day. 1 KB is too less. You can take 10 KB as well. I think that is fine. And we will still discuss it at scale, that how are you going to handle so many users and how are you going to have multiple distribution of storage, right? When we are going to discuss Kafka and how does it going to work out. Okay, makes sense. Does it look good? Even Advait, I will ask you one thing, that ask me this question in the end, like is 1 KB too big for WhatsApp, for message storage? Because I don't think so. I think 1 KB is good enough. We can discuss why I am saying is it 1 KB. Like I can divide it into multiple aspects and we can discuss, will 1 KB be enough or will it be less? Just remind me at the end because I might forget. Yes, we will be checking features, but I think first we just have to understand the estimations. No, recordings are not available, but I will definitely share the notes of the session. Okay, let's quickly discuss the queries per second as well. The QPS as well of this kind of system. Now tell me what is a query? Can you tell me what is a query? Okay, get retrieving data. Post, yes, get, post, send or download. Okay, right. Makes sense. Yeah, any query, either it is read or either it is write. Any query is a query, right? What is a read? Read can be, for example, reading a message, right? Or seeing a profile photo, or watching someone's status. All these are reads. What is a write? Write is sending message, changing name, sending status. All these are writes, right? In our version of WhatsApp, what do you think? What will be the read write ratio? If you can tell me. Right, I think there are 40 billion messages sent per day. So we can say, okay, there are 40 billion messages sent per day. Then what do you think if 40 million messages are sent per day, what will be the read write ratio? Will queries be in SQL or NoSQL? We will discuss in what is the storage we will use. So we'll use a Kafka. We will discuss it in some time, why we will use a Kafka, why we'll use a persistent queue in this. Okay. So certain examples, certain answers I am getting. One answer I am getting is 1:4. Another I am getting is 60:40. Another I am getting is 50:50 or 1:1, right? Or 4:1. This will definitely not happen, right? Because of course, reads will be more than writes, right? People will be reading more than write, right? So definitely that will not happen. Okay. This will happen or not, tell me. Will there be 4 times read as compared to write? Can be possible, but I don't think so. There is high probability in it. If we only take one-on-one messages, there is very, very low probability. Why? Because most of the messages will be cached. Are cached. For example, let's say Rajat sends a hi message to Harsh. So the first time Harsh is getting this message is a read. But is the second time a read? When Harsh is reading the hi message the second time? No, it's not a read, right? Because it's a just read from local cache. And it is really not going to the WhatsApp server for reading the message, right? So there will not be very high read and write ratio. Like there will be too many reads as compared to writes. Does this make sense? A quick yes if this is making sense. In case of group chat, we will cover it separately after some time, but let's design it for one-on-one first, and then we will see add changes in for the group chat. Otherwise, it will become too complex to understand everything in one go. In group chat, definitely, but yes, there will be more read than write since it will be sent to multiple people. Make sense? Will it be this? I think this will be the most best case. Like there will be somewhat more reads as compared to writes, because some people might be reading it on multiple devices, on phone or on WhatsApp web, and you have to do multiple reads. But definitely, this is the more right case, right? Does this make sense? So if read are 40 billion, sorry, if writes are 40 billion and there is a 60-40 ratio, what will be, how many writes will be there? There will be 6/4 into 40, right? Which will be 60 billion. So how many total queries are you doing per day? Around 100 billion. So what will be the QPS? Queries per second. you are doing 100 billion queries per day. So how many queries, let's say if the queries are equally distributed over time, what will be the queries per second? It will be 24 into 60 into 60. You can cut this by this, you can cut this by this. So it will become, let's say, 100 million by 24 into 6 into 6, right? You can say 24 as 25, and you can cut this by 4, cut this by 2, 3, 3. Let's take another 10 out. So if you take another 10 out, it will become 100k by 9. Let's cut 9 by 9. So it will be 100k queries per second. Does this make sense? Okay, sorry, this should be 1000. Yes, I am wrong here. So this should be 1000. If this is 1000, then I don't have to take out 1 here. So this will remain 1 million. And this will be 10. I will cut this by this. So this will become 1 million queries per second. Right? Right? So it will become 1 million per second. Is this making sense? Please again, last slide. When the message is received by you, it's not a read operation, right? Like the message is published by you, you are not querying the WhatsApp server to fetching. No, Sanket. There will be, it will be a read. Why it will be a read? Let me come to the design. I will tell you. There are. Let me come to the design, and you will understand why it is a read. I can, if you are very, very good at it, I think others can ignore it. But if you know how things work in a more sense, then there will be a socket which is going to be connected from the client to the server, or to basically a Kafka, which is going to connect it. But between those as well, there will be multiple layers. There will be load balancer. There will be a app server. And then between the socket and the load balancer is the message passing, right? So we will see how does that socket work out, and in that you will understand that actually it's a read. Right? Okay. Is it making sense? Just give me some time, and in the design it will start making sense to you. When we will design these sockets, then we will discuss what are these sockets. It is going to make sense. Okay. Is this clear till now? There are 1 million queries per second, which is a very, very high number. What do you think? How many queries one machine can handle? $2K, $4K, right? You are right. Right? How many queries one machine can handle depends on multiple factors, right? For example, the first factor itself is what is the machine configuration, right? Is this machine, give me some time, I will discuss it. Is this machine, how much processing does this machine have? How much RAM does it have? A bunch of areas. And second thing, it also matter is the query itself. Is this query a very heavy query, or is this a very low, light query? Depend on all these factors, but on an average, you can say 5K to 6K queries is something that a machine handles on an average. Let me just open a new tab, right? So does this make sense? So we have 1 million queries per second, and you can say a single machine will handle around, let's say, on a very good case as well, 10K queries per second. So how many number of machines do you require? Is around 1 million queries are going to be handled by 10K queries per second, which you can write it as 1000K by 10K. So more than 100 machines is something that you require. More than 100, 200 machines is something you require, even considering 10K is a very, very large number. And you need a very good machine who can handle 10K queries per second. Usually a machine handle 4K, 5K, 6K queries per second. Right. Does this make sense? And this is only for one-on-one conversations, right? So is this making sense? If you are designing something for one-on-one conversation, all these areas of how much storage do you require, how much queries do you require is very important. Once we start designing, we will take a look, how do we handle this storage, how do we handle these queries and everything, right? Let's move to the third step whenever you are designing a system, is to think about the design goals. In design goals, let's first talk about the CAP theorem. So tell me, in terms of consistency and availability, what do you think, which is more important when we are just let's cover this part as well, and then we will take a few minute break, right? Let's cover this and then we will take some break. Okay, consistency, availability. Some people are saying consistency, some people are saying availability. Okay. Okay. Yeah, I think both of you are right. However, in a chat application, chat applications are designed for consistency. Let me tell you why, right? Like both the thinkings are correct. We want to make our system as available as possible. Like whenever I am sending a message, I am able to send the message. It should not happen that it is not sent or it fails. Definitely we want that. But still chat messages are designed for consistency. Why so? There are two reasons for it, right? Let me discuss the reason one. No, recording will not be shared. So notes will be shared, but recordings will not be. So the reason one is that chat messages are human driven. What do I mean by chat messages are human driven? It means is that, let's say Rajat is sending a message. Let's say Rajat is sending a message to its manager Rahul, right? I want to send a message that I will be on Woof today. Let's say I send this message, right? And because WhatsApp is designing it for availability and not designing it for consistency, WhatsApp tell me that, okay, my systems are available. Even the message is not persistent at the storage. It says my systems are available. Let me say that your message is sent. But it is actually not sent till now. Or like it is not actually sent from my side till now. It is still not persisted in the WhatsApp storage. Does this make sense? And it sent me, it is sent, but it is actually not sent. So will that be not a very good thing? We don't want these cases to arrive, right? That we send the user, set the user that we have completed this action, but actually not go about completing it. WhatsApp has DB for a short duration of time, right, Rishabh? We are not saying WhatsApp does not have any storage at all. If you remember, what we discuss is that if this is Rajat is sending message to Rahul, then Rajat, if she's sending a hi, then WhatsApp will persist it. Will persist the message or will store the message until the message is delivered. That is why we are discussing so much about storage of WhatsApp, that the storage will be around 100 terabyte, right? That is why we are discussing all of that. Okay. Okay. So tell me, if I send this message to Rahul and Rahul does, and WhatsApp tell me that your message is delivered, that your message is sent, but it is not sent internally, will that be a good thing? Yes, no? No, right? That will not be a good thing. So definitely our system should not be inconsistent, but can it be eventually consistent? So we get to know that our system should definitely be not. If we design having a system that is not consistent in WhatsApp or a chat system will definitely not work. But can we make it eventually consistent? What does it mean by eventually consistent is right now WhatsApp will tell me that your message is sent. And even if it fails right now, it is going to send after some time. Or if it is even not sent, it will tell me that your message is failed. Message sending has failed. And retry it. Will that be fine? Right? That it said that my systems are available to take the message, send the message and go back. But then I tell you that, okay, your message has failed after some time and send it again. Does this make sense? Right? Okay. This is fine. In this case, it is definitely fine. However, there is reason 2 as well. Why we should not even have eventual consistency is messages have context in conversations. Right? When we are doing conversation, the order of the messages, or I would say, carry some context. For example, let's say Rajat and Rahul are having a conversation. I sent a message, hi. Rahul sent another message. I sent another message 2. Rahul sent message 3. Then Rahul sent message 4. Rahul sent message 5. I sent message 6. Rahul sent message 7. Then this will be an entirely different conversation. If the conversation will be hi, message 2, message 3, message 5, message 4, message 6, message 7. Then this might be a very separate conversation and can have different meaning. Right? Does this make sense? So the order of the messages carry value. Is this making sense? Right? That is why what will happen if you design a system to be eventually consistent? Eventually consistent means that right now, as you are doing live conversation, these can be out of order. What does eventual consistency say? Eventual consistency say that right now, these will be out of order. That is fine. After some time, they will definitely be in order. Eventually, you will start seeing them in order. But right now, as you are doing conversations, they might be out of order, which is something that again will not work. And it's not a very good thing in a chat application. You have to maintain the order of the messages, which is very, very important. That is why messages are designed for highly consistent. Like they should be consistent. And then you will design them as to be as available as you can. Okay. And partition tolerance, so definitely you will need if you are designing any system. Right? Maybe. So again, I just want to mention one thing here. Harsh, like everyone, like in the chat, I don't know how does WhatsApp actually work, right? How does the design of WhatsApp actually work? No one knows, right? Only WhatsApp knows how their design internally actually work. What we are doing in this class right now is trying to understand if I want to build something or if we want to build something like a WhatsApp, then how we are going to do it. There are always trade-offs to every design. You can definitely say that it can be available, and I am not saying it cannot be available. You can design it to be available as well. Just what you should know is, if I design it to be available, then what are the things that might happen? Then it's your business decision whether you want to make it available or you want to make it consistent, right? So I am not saying whatever I am saying you, whatever I'm designing here is what WhatsApp is using. I don't know what WhatsApp is doing. I don't even know, like no one knows what WhatsApp is doing. What everyone can tell you is, how can you design such a system? What are the trade-offs of multiple designs? What if you do this, what will happen? What if you do this, what will happen? And then finally, you will take these decisions when you are inside an organization with your manager that, okay, this is something we can take. Okay, let's move forward. So let's also discuss about latency. If this is clear, tell me, what do you want? You want high latency or do you want low latency? Low latency, right? What is latency? Latency is time that it takes for you to come back, right? Like, for example, let's say, how much time does it take? Let's say you are firing an API to a system as a user on your local device. Then how much time you send the request on T1 and you get the response back at T2. So how much time does it take is overall is latency. So you definitely want low latency. Can you give me some example of high latency systems where it is fine to have high latency? Yes, emails can be that part. Notifications can be those part. Video processing can be those part, right? So all of these can be somewhat have high latency. Can you give me some example where availability is important? Some example where availability is important. Yeah, I think all of these are live, right? Live streaming, you will design for availability. Even if some, let's say if we cut, like say if internet is slow and you cut some segment of it, you will still show the recent segment. So live streaming is important. News feed, you are either scrolling for Instagram or anything, news feed availability is important, right? All of these. Consistency is more important where transactions are involved majorly, right? Like, for example, if you are doing IRCTC booking, you will design it to be consistent. Doing any booking, something available, consistency is important, right? Okay, I think makes sense. After this, let's move to design goals. Do you want a few minute break or do you want me to cover some aspect of design deep dive and then move forward? A small break. Okay, ठीक है. Okay, let me leave you with a question, right? And then let me do one thing. So that let me leave you with a question in just 2 minutes, and then we can come back and then again start designing the complete thing. And in the meantime, people can think about that question, right? Okay. So I think the question that I will leave you with is that okay, so maybe let me leave you at this question. Is right now, if you see your design, can you tell me what are some of the very, very important aspects that you need? One aspect that you definitely need is that you have to scale in terms of storage. and in terms of your QPS, right? Second thing is your latency should be very low. One more thing that is very, very important is that your system should be consistent. That is, order of messages is important. It's not just about sending message. It has to be about sending messages in the right order, right? Another thing is that what if a message fail? What if a message sending fail, right? How will you retry this message? Right? Then also think about connections. How will the connections work? Okay. How is the message going to transfer between local to the system? Like what are the different system that will you use? Will you use WebSocket? Will you use long polling? Will you use HTTPS, right? So think about these problems, right? That how are we going to solve all these problems? Let's start discussing these problems and let's start solving these problems one by one, right? Let's start with a very basic design. Let's start with design one, a very basic design, and let's make some corrections on it, and then we will make another correction to come up with our final design, right? So definitely some of the things that are happening is that we have this client system. We have this client device, I would say. Let's say Rajat is sending a message to Prajwal. Right? Like, let's say Rajat is sending hi to Prajwal. Make sense? So Rajat sends a hi to Prajwal. So tell me, how will everything go? This is Rajat. So the first thing that will happen is that this message will go to the load balancer. Right? Make sense? And the load balancer will send the request to one of the DB to persist the message. Persist the message. Yeah, definitely. DNS will happen. DNS resolution will happen. It takes the IP address of the load balancer. Then it is going to go to the load balancer. Yes, you are right. Skipping those, but yeah, definitely you are right. After load balancer, we will make the app layer as well. So we will definitely come to it. We will also come, how do we establish connection and everything here. Right now, let's just think of one message that is sent, then we will draw connections and WebSocket and everything. Okay. So this goes to essentially a DB, where this is going to persist the message. Once this message is persisted, then here is Prajwal, which is also connected to another load balance. Right? Here will also be a connection that is established here. Right? Now this message is going to be sent to the load balancer and is going to be sent to Prajwal. But there are multiple cases, as we have already seen. If Prajwal is connected to the load balancer already, right? There is a connection established between Prajwal and load balancer right now. Let's say there is a live conversation going on, or Prajwal is active right now. So this message can be sent directly. However, if there is a disconnect here, then it has to be retried. Make sense? For app, what does the DNS? Okay. So you guys know, right? Like, how does DNS resolution take place, right? So whenever you are sending a request, either you are sending it from a mobile phone, you are sending it from a browser, you are sending it from any client, right? It can be a mobile phone, or it can be an app, or it can be web, or it can be anything, right? It can be like Postman as well. Then basically the request goes to DNS if it is already not stored in the cache. The device itself cache the IP address in itself, like the result of the DNS itself. You give the domain name to DNS server, and the DNS server gives you the IP address of the load balancer associated with it. The next time you hit the request, if it is already cached, you directly go to the load balancer and you don't have to essentially go to the DNS server. Like all are just clients. Okay. Now this makes sense. If it is disconnecting, then we have to retry. Right? So now let's think of different things in this. Does this make sense? At very small scale, if we are not scaling, then this is how the system will look like, right? Now tell me, how do you design the system at scale? In terms of both storage and QPS. Let's solve this first problem first, right? Messaging queue we will come to, but messaging queue is when we will solve the retry problem. But let's say the first we are just solving the for storage and QPS, right? Okay, makes sense. So tell me, how will you store the storage problem? You have this 100 terabyte of data that you need to handle. How are you going to shard the data? Will it be based on user ID? Yeah, tell me, will it be based on user ID? Do you believe that it's like, a message is coming and the message is going? Do you believe in this, that it's kind of first message that comes in will be the first message that will go out? Right? It's kind of a FIFO thing, and you are not essentially storing for every user. For Telegram kind of system, definitely sharding based on user ID makes sense. However, in WhatsApp kind of system, you're really not storing messages for a longer period of time. You are just building that a message should come and just should go out. So don't you think you have multiple options? Like either you can shard based on timestamp, right? Either this is something that you can do, you can shard based on timestamp, or you can do something like round robin sharding and check with storage available or not. Does this make sense? Is this making sense? So let's say I am getting a lot of these messages. And I have multiple databases. So one way that I can store these messages is that let me divide based on round robin. I will have the first message here, check whether availability is there in the database, and then we'll send the second message here, third message here, fourth message here, fifth message here. So essentially, within the load balancer, I will store certain aspects. I will store machine ID. Let me just draw it here. I will store machine ID. Then I will store whether this system is available or not, right? Available to take storage or not. And then based on that, I can just do a round robin. Does this make sense? Is it making sense? A quick yes. Something like user ID does not really make sense because you are essentially going to delete a lot of data from it. So you don't want to design something here that is related to the user. Does this make sense? A quick yes, no, if this is making sense. It will be too many sharks if we do it with user ID. Why do you think so, Anonymous, that it will be too many sharks if we do it based on user ID? We can have 10,000s of users in one database. But it does not make sense because the data is getting deleted very quickly. The profile details you can definitely store based on user ID, but messages itself does not need to be. Right? So one aspect that is in terms of that we can do here is from our earlier design, right? We can at least do one design. Like we have the client here. The client sends is connected to a load balancer, right? What is this connection? We'll talk about sometime. Is connected to a load balancer. The load balancer, once receives a message, is going to send, there will be multiple app layers here, app servers, and then there will be multiple databases here. It is going to send a message to a machine, and then the machine is going to send a message to the database, which can be sharded based on round robin or which can be sharded based on timestamp as well. Since again, you don't care whether those messages will be retrieved later or not. So you need a good way of just distributing the messages equally between the available servers, right? That is what just you want to do. If I have 10 databases that are available, let me just send the request equally between the 10. Sharding means dividing. Sharding means I have 10 terabytes of data. I cannot store it into a single server. But can I store small data in different DBs so that combinedly they contain all the data? But single one do not contain all the data, right? Once I receive this, then it is going to send the request to another machine, which is going to connect it to the load balancer 2, which is going to connect with, let's say I'm sending a message to Ankit, which is going to be connected here, right? This is one aspect. Now tell me, how will you, Manasvi, just give me 1 minute and I will explain it again. How will you retry? So let's say I send a message at T1. At T1, I send the message from Rajat to Ankit. And let's say then I retry at T1 plus 10 seconds. What is the next time I should retry? Should I retry at T1 plus 20 seconds? And then at T1 plus 30 seconds? So at a gap of 10 seconds? If I retry at the gap of 10 seconds, don't you think that there will be too much bombarding of retry messages? Let's say someone is not available for 6 hours, but I am retrying continuously for that user. Right? Does this make sense? So what happens in this case is, whenever you are doing retry, you should go about figuring out a algorithm which uses exponential backoff, which means at t1 plus 10 seconds, you will again retry. But then you will retry after 20 seconds. So you will retry at t1 plus, here you have 10 seconds of decay, but here you have 20 seconds of delay. Right? Then you will try at 40 seconds, which is t1 plus 70 seconds. Then you should retry at 80 seconds. And similarly, you should keep on increasing the time frame in which you are retrying the logic. And that will make sure that your system is not bombarded with retry logic a lot. Right? Does this make sense? At random interval will not be very good frame to do it. That is what we are trying to figure out. How should we retry? The user reliability. It depends on online. Yes, multiple scenarios. There are multiple scenarios, right? If a user comes online, then either you can do a push to the user, like either the user can say that I am online now, give me all the messages that are there for me, right? Or you can have a trigger based that, okay, I will send the trigger in and then I will get the messages. Is this making sense? Some aspect, let's discuss the trigger aspect as well after this. That once let's discuss this, let's also discuss how will the trigger based work out. Like if we are doing a trigger from the user and then it is, do you see any disadvantage with the trigger based? Okay, let me just cover trigger based after this. Let's stick with this and then use trigger based algorithm after this and then see the aspect of it, right? Okay, if you are using this, if you are using exponential backoff, how will you design exponential backoff? Can you tell me what is the best way of designing a exponential backoff? The best way of designing a exponential backoff is a persistent queue. Can you give me some example? Do you know about a persistent queue like Kafka, RabbitMQ? So what happens in a persistent queue is there are multiple queues associated with a Kafka or RabbitMQ. So let's say this is a Kafka or RabbitMQ. There are multiple queues. For example, there is a fast queue, and then there are further more queue. For example, let's say a medium queue or a slow queue. So when a message is sent, a message and a user is sent, then it will first go to the fast queue. And it will try to send the message to the user. If the user receives the message, then that is great. But if the message sending fails, then you retry in a medium queue, right? Does this make sense? ठीक है Kashi, let us draw it again once again. After this, let us draw it one again, and I think that will make sense, right? Then it will go to the medium queue. If the medium queue does not runs at half the speed of the fast queue, and if the request even fails here, then the request goes to the slow queue, which even runs even half the speed of the medium queue, which makes sure that you are retrying after some delay of time and not bombarding the system with just retries and not actual new request. Does this make sense? Now let's cover few things. Let's cover few questions if this is clear till now, and see what can we, how can we complete the design. One question that is prominent is trigger based, right? Like one question that I saw earlier is, let's say Rajat sends a message to Pankaj. Now Pankaj comes back online. So should Pankaj pull the messages from WhatsApp? So if Rajat is sending some messages, then definitely messages are there on WhatsApp server. So rather than we pulling messages to Pankaj, when Pankaj comes online, Pankaj should pull the messages and get it from the server, right? Just give us some time, Vijay. Let's complete everything, and then I think it will make sense. Is this also making sense that we need a mechanism like this as well, right? However, having a mechanism like this, what type of sharding do you need? Can you do sharding based on like timestamp or round robin here? Or you will need sharding based on user ID? You will need based on user ID. Why I am saying so? Because it might happen that Rajat might have sent 10 messages to WhatsApp to Pankaj. Now Pankaj wants to get all the 10 messages, right? Or might have Rajat and Satvir or Kushal might have sent different people might have sent messages to Pankaj. So Pankaj will have to pull all those messages from the WhatsApp server. If you're not designing it based on user ID, you have to go to multiple DBs to get those messages, which will be very, very slow. So you have to divide based on user ID. Does this make sense? Okay. Is this clear? A quick yes. For real-time communication, we cannot have a pull or push mechanism. We cannot have a pull mechanism, right? Like it cannot happen that you are having real-time communication and Rajat and Pankaj is pulling every 1 second from the WhatsApp server that do I get a new message? Do I get a new message? Do I get a new message? Do you think that will happen? Like Rajat, Pankaj will keep pulling from the system that do I have a new message? Do I have a new message? Give to me. Because in that time, most of the time, the request will fail. You will not get a new message and you will get a null response. So for those communication, real-time communication, even when Pankaj is internet is enabled, but he is not doing real-time communication, in all those things, pull like push mechanism, like a RabbitMQ or Kafka will make more sense, right? Is this making sense? A quick yes if this is making sense. And then let's think of another design, right? Like let's start thinking of, for example, if this is the client is sending message to the load balancer. The load balancer send message to one of the app servers. Now there are multiple databases which are persisting the messages, right? So, and there is Kafka as well. This is for real-time communication. Make sense? Right? Is this making sense? A message is coming from, let's say, Rajat, goes to the load balancer, goes to the app server. The first thing that WhatsApp will try to do is to send this message real time to the customer, right? To the other person. Let's say I am sending it to Raghav. So it will send the message for real-time communication. Like let's do a real-time conversation, send it to a Kafka machine. The Kafka machine will have retries logic built in. Make sense? Multiple queues which are retrying, which are trying to get the message delivered. So the first time it will go to the fast queue. It will try to retry. If the message is successful, right, then it will send it to Raghav, right? If it is not successful, it will retry few times. Make sense? And even if after retry it is not done, like if it is not being able to send, after maybe we can do something that after, let's say, 5 minutes of retry or 2 minutes of retry, or after 10 number of retries, whatever it is, then this message will expire from Kafka and will go into a storage which is sharded based on user ID. Is this making sense? And then the user will, from this database, if the user comes online, it will be pulling the message. And Kafka will not be sending it. Now I can unmute any one person and I can answer some questions and see if we are able to find logic in the design. Anyone who wants to get maybe have some conversation around this. Can you write in the chat window? If someone is not able to understand, we can have a small conversation and try to see what is that you are not able to understand. I can unmute Govind then. Okay, Govind, I have unmuted you. Are you able to hear me?
Am I audible?
Yes, you are audible.
Yeah, what I understood so far is that whenever users send message, it goes to the load balancer and load balancer send it to the appropriate machines. And then machines send back message to the real-time Kafka servers and it will retry for that particular.
Will try to send the message to the
Yes.
concerned person. If it succeeds, then that is good.
Okay, I just want to click what does it actually retries, whether it tries to get you check whether user is online, or does it try to actually send that message in that Kafka
It
server?
tries to send the message. Now, what are the different, why do you think a message sending can fail? One obvious logic for message sending can fail is that the user is offline, right? If
Okay,
I'm
yeah.
sending message to you, you are offline, message send will not succeed. Are there other cases where message sending can fail?
Okay, like mean that Kafka server again talks back to the another load server and like load balancer and get back to user. Like check whether that message sending is success or not.
So
Or
if the
does
user is online, then it will be connected to one load balancer, right? It will not be connected to multiple load balancers, right?
Yes.
Right. So
Yes.
it will, if the user is connected, but still the message send does not happen, maybe something went wrong within the system. So it will try to retry again,
Okay.
right? And maybe try again, but it will not try with the same frequency.
Okay, like suppose I am on the network, I just send message and it like just switch to the another network. Then does the user get connected to the another load balancer, like through the another machine or what else?
But if the user reconnect to the
From the another network, like suppose I am using Geo and switch back to the Airtel,
Hmm.
does that user connection stays with the same machine or same load balancer? Or,
I don't think so. It will stay on the same load balancer. Is there any advantage of staying on the same load balancer? I don't see any advantage of connecting the user again to the same load balancer. So I don't think so that the connection will establish to the same network. It can be to different machines as well.
okay, like just so far, like the overall flow will be user will send the message, it will go to the one load balancer will forward message to appropriate machine, then it will goes to the Kafka real-time server. It will tries first on a fast track. If that is not succeeded, then it will tries on medium, it will try after some delay. And it will again, if that is not success, then it will send on slow track. If, even though after that is not successful, then it will forward back to the sharded database. So whenever like user get back online, then user can ping like pull the data from the sharded database, right?
Yes. Yes.
Okay. Okay. I think like I understood. If anyone has any other doubts, like they can ask or you can unmute them.
Yeah, sure.
Yeah, thanks.
Sure. ठीक है. So Rishikesh 5 minute is an example. Of course, you can take there can be multiple approaches. One approach can be that Kafka will keep on retrying for 1 day or 5 minutes. But after 2 retry, it will send the, like one thing that can also happen is that Kafka after 2 retry can send the message to the sharded database and still keep on retrying for 10 more times. Right? So there is of course a trade-off. If you do this, then you will fill the sharded DB a lot more. But if that is not a concern for you, you can do so as well. Right? And that will be through which if the user comes online after some time itself, you will be able to deliver results faster. So the load balancer of the receiver is the consumer. Yes, is the consumer of the message Kafka pushes. Yes, you are right. Yes, yes, Anand. So message which is not delivered can be stored in user sharded database through which the user can pull messages rather than having a push mechanism from the system to the database. Is there anyone who want to ask a query or like discuss something? Okay. So I think I can unmute you, Kashi. Okay, I have unmuted you, Kashi.
So, hi, I have a doubt. So, what I have understood is that it will be a non-relational database, right? Because because you mentioned CAP algorithm and
Hmm.
availability is not always the case. So it is going to be a non-relational database, right?
Okay.
So when a user send a message and it goes into DB,
Hmm.
now if it is going into DB, then we will always having a receiver and a sender ID in the message, right? In the message block.
Yes.
So,
Yes.
so will it be saved in both the partitions of the DB with receiver and the sender ID, or will it be, or the sharding will always be based on the receiver ID, and it will be stored there?
Okay. So the message will be stored based on receiver and consume receiver and sender ID both, or just on
Yes,
receiver ID, right? That is the question. So you
and
tell me what like let's try to think of it. Okay, let's try to think of it first, and then we can take out another question. So the question is, you are sending, Rajat is sending a message to Kashi. So the message is definitely a message. Now Rajat has sent the message. Kashi has not received the message. So from Rajat, it is message is sent, right? It is also persisted in the DB. That means that the message has been sent, but Kashi has not received any message, right? So the Kashi will do the pull, right? So the message, so the Kashi will be pulling the message. So the sharding should be based on receiver ID,
okay,
right?
got
Let's
it.
say it was Telegram, then what will happen? Then in future, Rajat and Kashi both might have pulled the message, right?
Yes, yes, yes.
Because it is like you can view the message from a different mobile phone and everything, and you can both pull the message. So in Telegram system, your message has to be stored on sharded, stored in two places. One based on sender ID, and one based on receiver ID, right? Does this make sense? Because then you have to pull the both might have to pull the message. If
Got
you do this, then there is duplication of data, right? You're duplicating the same message two places, right? Duplicate handler consistency, right? Because
Yes, yes, yes.
let's say sending here succeeds, but sending here fails, right?
Yes.
Then message is sent from the sender but is not received from receiver.
Yes, receiver.
So then you have to make this a transaction. You have to make these two operations into a transaction, so that if any one fails, then the whole operation is reverted back, right? But WhatsApp does not, I think, have all these scenarios. So you can just shard based on receiver ID. Does this make sense?
Yes, yes, yes. Got it.
Okay. The second question, you were having one more question, I think.
So that was related to this thing only. So in the second case, let's say we have a Kafka layer. So Kafka layer don't make much sense in the second case, right? Uh, because WhatsApp is making the advantage of Kafka by not storing everything into DB. If both are online, then it just send the fast track the message. So in the case of Telegram or any other chatting channel where we have cloud storage, so Kafka doesn't make any that much sense as it make in case of WhatsApp, right?
So then how will you do real-time communication? Because Kafka, in short, there is a push mechanism.
Yes, yes, yes.
But then will you have pull mechanism, or will you have you have pull mechanism via WebSocket, right? A WebSocket will keep on listening to,
Kafka.
like in Telegram, the WebSocket will keep on listening to a change, right?
Mhm.
And then once that change happens, you will send it to the yes, I think you are right. In Telegram kind of system, you actually don't go about needing Kafka.
Mhm.
You can, because you want to store the messages and not delete them, then you don't need kind of like a Kafka kind of thing. You can just have a WebSocket which keeps on listening to the change happening to the user database. And if there is a change in the user database, reflect it back to the client, and then the client will render it at the correct place.
So one just last question. If we are not diverting from the topic, then you can answer it right now or you can answer it later. So then in case of Telegram, do we need a no? So you mentioned this, that we have to make it a transaction, right? So we need to make sure of consistency here by making it a transaction. So do relational database make more sense in the lower layer or non-relational? Because if we have relational database, then what we can do is that image or videos, whatever files we have, we can store that into non-relational or file storage, and we can have the link to that in the relational table itself, so that consistency is maintained within the table itself using the relational database. So that is just last question. So you can answer it in the end if we are
Can
diverting
you
from the
repeat
topic.
the question once? So like in short, can you repeat it? So you mentioned that, yeah, can you repeat once again? And
So here, if you see in WhatsApp, we are storing in the database on the basis of receiver ID, right? But in Telegram, we need to store on the basis of both sender ID and receiver ID, because both are pulling the messages, right? So that is actually duplicating, and that will increase in storage, right? If it is 1 TB, then it will be 2 TB in case of Telegram minimum. Now there are other challenges in that as well. But if we see, if we are persisting everything, that then why can't we do in the form of table, in the form of relational database? So we have sender ID, receiver ID, and then the message. And if it contains any image or unstructured text or field, then we can store it in file storage or some other storage and put a link in the table itself. So will that be more beneficial, or still no relational database make more sense?
Okay, so you're saying ki let's store the message in completely a relational database so that you can do query from two keys, right? You can query based on sender ID as well. You can query based on receiver ID as well. Okay, rather than storing it at two places.
Because the operation will be much faster, right? The read operation, the fetching of the data will be much faster in this case.
So let's say I have a relational database. This is a table I have, right? Now you are saying I put in a message here, and the message will have multiple things. It will also have a sender ID and it will also have a receiver ID. Okay, makes sense. Now this table will be too big to, the problem is this table will be too big to be in one server, right? Or one database. है ना? It will not have come in one database. Now divide it. How will you divide it? How will you like shard it? Now tell me. We are not like, essentially it's not a problem of relational or non-relational. The problem is when you have a lot of data, you have to shard and store it in multiple database. Now how do you go about storing it is the actual challenge, right? So I will store it, like I can still have relational, like
But
what I'm saying is, let's say I have relational DB, but I will still store this message both for sender and both for receiver.
To make the read operation much faster, right?
To make the, because I have to, like, not to make something faster, because I have to support that after some time, if someone is retrieving the data from the database, I should be able to tell them, see one thing. Let's say I don't, let's take your case and try to understand, will there be any error that comes, right? So let's say, now you tell me, how will you divide this? This is going to be out of, this is not going to work out. Too large to store in one database. I have to divide this into multiple database. How will you shard this database?
Got it. There will be problem because if it do on the basis of sender ID and receiver ID is in some other server, then the problem will be that we will be like in a recursive loop of finding that receiver ID. Either we need to store the metadata, but that also will complex the system. So we need to maintain the two copies always so that it is always very faster.
Yes. Yes. Even if there is sender ID and receiver ID, and you say that is fine, let me just divide this and store it here, right? And then the user is here. Now, let's say I open Telegram and I am a receiver. Now I am getting messages from hundreds of users. Here is user 1. Like, let's say user is sender 1 and receiver is user 2. Now I am also receiving from user 3 and user 2. If you are sharding based on sender ID, then you will might store this in another database, right?
Yes.
This wali entry you might store in another database because you are sharding based on sender ID. And then when the receiver is opening mobile, it can get message from this in fast. User 1, it can get fastly. But then what about user 3? It needs from user 3 as well. It needs from other as well. That will be slow. So it's not really the problem of relational or not relational.
Yes, got it.
It's the problem ki how do you handle data at scale so that your operations are first reliable. The biggest problem comes with data into multiple database is reliability. Some database will fail and your API failure will increase, right? If you're querying just from one database, your reliability, let's say, is 99%. If you query from 3 database for the same result, your reliability will decrease at scale, right? It's not talking about 10, 20 requests a day or 100 requests a day. When you're talking about billions of requests a day, it fails. Reliability makes a issue, right? Like, and very hard to solve. Like, I remember being at PowerPoint, we were just solving for reliability from 98 to 99%. And it was like heck of challenging just to get that 1% extra reliable. But users care for it. Like, your Google Doc is not working one time, you will not be happy. And PowerPoint essentially on online does not work a lot of time. So that's a very big challenge that has to be solved, right? So yeah. Yes, I think makes sense.
Yes, got it. Thank you.
Okay. Anyone else want to ask anything? Rishikesh, do you still want to ask question? I should unmute you. Okay. Okay, so I have unmuted you, Rishikesh.
Thank you. So what I wanted to understand is, so let's say when Kafka is retrying, so after whatever threshold limit, be it number of retries or after a particular time period, it stores that message in some another storage. So before that, before it happens, if the user comes online, so will the user pull the message himself, or how will it actually work?
See, again, there are trade-offs, right? I don't know how does it actually work, but I can just tell you trade-off. You can decide what to do. One thing that I can do is send message to Kafka, fail once, send to database, right? Sharded database, and retry as well. Do both things. Okay. In this case, when the user comes out, even before retry is done, then it will get the message directly from the sharded database, the response will be fast. Latency will be very low for even those cases is when user is coming back online, right?
Right.
Makes sense. The second is I do send message to Kafka. If it fails, then retry for some threshold. And it can be time, it can be number of retries until it is not hit. Once it is hit, then send it to sharded database and then retry for some more time. Right? In this case, if the user comes back before retry is done, then it will not get a response from here. Is it making sense?
Yes.
Right? But it will get the retry, it will get the response once this retry is happening again, which is going to be less time because again you are using exponential backoff. Exponential backoff is very fast in the beginning, but keeps on slowing down later on. Right? Make sense?
Yes.
So there is some amount of delay, but this some amount of delay will save you what? Will save you a lot of resources at scale. But again, it's your decision whether you want to go with one or two. But there are trade-offs. In two, there will be somewhat more.
Okay. Understood. Understood. Thank you.
Okay. Okay. Anyone else? Anyone else want to ask anything? Any? Shailesh. Okay. Yes, Shailesh, I have unmuted you.
Yeah, so I have a question here. In Telegram, what happens is we see 1 lakh or 2 lakh subscribers of the channel. How do we send messages to each of them? Don't we need queue over here?
Yes. So when group messages are concerned, like I will not be able to group today, but if group messages are concerned, group messages are usually of two types. One is small groups, which actually WhatsApp works on, right? Like WhatsApp does not allow you to have more than 500, like I think 1000 is the limit nowadays. Earlier it was 254. It does not
Right.
allow you to send messages to a lot, like does not allow you to create very large groups. But
Mhm,
this does, like Telegram does, right?
mhm.
So both are work differently. In this, if the number of people who are going to receive the message are less, you can fan out, you can use a fan out approach. Fan out approach is again send the message to one of the queue, and then this queue will make sure to send message to everyone. Right? Again,
Right.
this will only work if group is small. If group is large, then you will send a lot of requests, and that will burden your system a lot. If it's a Telegram kind of system, then most of the times user is pulling the message.
Mhm.
That is why you will see that you most of the time you will not receive notifications from very large groups.
Okay, so if it is
Or
usually
not.
showing the message here,
Hmm.
do we need to use some kind of different algorithm than the queue messaging? For example, Redis publishes subscriber. Is that would work, or that is also not a good choice?
Why would we use Redis? Right? Like
My thought is basically we can create a channel in the Redis by the name of the group name, and we have the, let's say, subscriber subscribe to it, and as soon as the subscriber comes online, pull the messages from the channel.
so you keep on pushing messages to a Redis, and
Redis
then,
channel, yes.
yeah, and then Redis has a lot of subscribers. Once the subscriber comes back online, it will pull the message from the Redis.
Correct.
Okay. What if there are 1 lakh users on the channel? Only, however, 20 users are not coming, have not come online for a year or something. So will you keep that message on the in the Redis?
No, we cannot keep it. That's why I thought Redis is one option, but it might not be a good choice. What is a better
Might
choice
not
than
be.
Redis?
It might not be a good choice because the Redis, it is important you don't, Redis is only needed when, like Redis you need when you want to delete message. Like you don't want to keep message in Redis for a very, very long time. Otherwise it will keep on filling. It's used for very small amount of time that, okay, you use it and like cache, it's kind of used like a cache in memory cache. So
Right,
in this
but,
case, you will not use it.
But this use case could be useful for if the user is online.
If
But
the
if the
user
user
is
is not,
online, definitely you can use either Redis type of cache, or you can use like what is like we are using a messaging queue. But a messaging queue gives you an advantage is these Kafka are persistent. They are known as persistent messaging queue. What does it mean by being persistent? By persistent, it means that they will not lose information for sure, because they have the slow, fast, like fast, slow, slower queues, which keeps on working in the exponential back-off manner. So they don't also kind of burden the system with a lot of requests, but at the same time, right, like persist the message within them until the eviction policy is hit. Right? Makes sense? So if you have a first in, first out approach, right? If you have a queue approach towards thing, like the first message that is coming should be the first message that gets out. Mostly you use a persistent queue. If your use case is not like that, if your use case is just a subscriber and a subscriber model, then a Redis is a good approach towards solving things.
but for in Kafka persistence as well, the user is coming after, let's say, long period of time. It doesn't fetch the message directly from the Kafka, right? It will
Yes.
fetch the message from the some storage, the persistent storage like Cassandra or MongoDB.
Yes, definitely. You can do this. Yes, so you are right. You can do this as well. You can send the message first to a Redis. Whoever is connected to the Redis at this point of time, or in some time, will be send messages very quickly. But all the other users have to pull the messages from the have to pull the message and not
Alright.
right.
Okay.
Yeah, makes sense. Okay, I think anyone else? Good question, Stuti. FIFO will make sure that the messages are sent in the correct order. Actually, client will make sure that messages are sent in the correct order. So if you think of how do you maintain the order of the messages, Redis might send it earlier or at later because of the retry logics and everything, right? But every message will have message ID, and it will also have a previous message ID associated with it. So when the client gets the message, it will get the message ID and previous message ID. And if the previous message ID is already delivered, then it will show the message ID, otherwise it will not show. So actually client makes sure that the messages are delivered, are shown in the order to the user. It's more like how does YouTube works in chunks, right? Like YouTube is already downloading further part of the video, but it is showing you in small chunks, right? Chunkifying the videos. And how to maintain the order of those chunks is something the client is handling, not server. Using some of the pre-knowledge that, okay, which is the chunk before me.
I hope you found the class to be useful. If you did, don't forget to like the video and subscribe to our YouTube channel. This helps us create more such valuable content for you. And in case you have any doubt, please let us know in the comment section and we will answer your queries. Also, don't forget to check out the Bosscoders program, which will help you become a top 1% software engineer.